For this video, I'd like to discuss how to add fractions. And before we actually try to compute this, we first want to get an idea of what each of these fractions actually means. So let's start with this 1/2. And one of the ways that we can essentially model this is as a fraction of a circle. So let me draw a circle. And with this model, essentially the denominator is going to tell us how many times we split the circle. So since the denominator is 2, we're going to split it down the middle into 2 different parts. And then the numerator tells us essentially how many of these pieces we have. So we have 1 of them. So this right here is a representation of 1/2. And let's do the same thing with this 1/3. Let's create a circle model for that as well. And then we're going to split this one into 3 pieces. And one way that I split this is essentially I draw 3 points on the circle that are evenly spaced, or as close to evenly spaced as I can get them. And then I'll draw the center point, and then essentially just connect these with lines. And again, the numerator of this fraction just tells us how many of these pieces we actually have. So we have 1 of these pieces. And there are different models we can use, and we'll look at another one in the next example problem. But for now, we can at least ask ourselves, how do we add this piece to this piece? And I encourage you to think about this for a moment, but you may notice a problem. And the main issue here is that the pieces are not the same size. Let me write that. And since the pieces aren't the same size, the question becomes, how do we even add these together? Because it wouldn't really be fair to say that there are 2 of these, because they're essentially 2 different things. So that is the question that we're left with. Essentially, how do we add these pieces? And what you'll hear often when dealing with fractions or adding fractions is that you need to find a common denominator. So I'll write that down as well. So we need to find a common denominator. And remember, this 2 and this 3 here, these are the denominators of the fractions. And so we need to find a common one. And one thing you can always do is just multiply these 2 numbers together. So we can just do 2 times 3, which gives us 6. So 6 would be a denominator that would work for both of these fractions. So essentially what we're going to do is, instead of cutting this fraction in half, we're now going to cut it into 6 pieces. So let me draw in those lines. So essentially we're splitting each of these halves into 3 pieces. Though we also need to split this 1/3 because the denominator used to be 3, but now it's going to be 6. So essentially each of these thirds is just going to be cut in half. So let me draw those in quickly. And now that we have a common denominator, you might be able to notice that we essentially have the same size pieces now. So let me make note of that. So this leads to the same sized pieces. And notice we essentially have 3 pieces over here, all the same size, and we have 2 pieces here, all the same size. So now we can actually add them. And in total, you can say that there are 5 of these pieces, but there's 5 pieces of the circle where the circle was cut into 6. So the end result of this is that we're going to get 5/6, because if we add these together, we would essentially have 5 of these pieces, and we're talking about a circle cut into 6 pieces. So this is at least the way to solve it using pictures or models. But we ultimately want a mathematical way to solve this. So let's rewrite the problem down here. So we have that 1/2 plus 1/3. And like we did above, I'm going to find a common denominator, and 6 is what we're going to use. So I'm going to rewrite these fractions with a denominator of 6. But essentially notice that in each of these, I had to change the denominator. So you want to think, what did you multiply 2 by to get to 6? And we multiplied that by 3. But you can't just multiply the denominator by 3, or else you're going to change the fraction. This would change it to 1/6, and 1/6 and 1/2 are definitely not equal to each other. So in order to keep the fraction equal to 1/2, we have to do the same thing to the numerator. We also have to multiply this by 3. So then our numerator over here becomes a 3. So 1/2 and 3/6 are equivalent to each other. And then over here we have 1/3. And again, you're asking, what did you multiply 3 by to get to 6? And since you multiplied by 2, we're going to have to do the same thing to the numerator. And 1 times 2 is just 2. And then once you've found the common denominator, you're essentially just adding these two same-sized pieces together. So we have 5 of those pieces, but each of those pieces is a 1/6 of the total circle, you could say. So essentially, to add these fractions, once you find a common denominator and you're able to change the numerators to their correct values, then you just add the numerators together and the denominator stays the same. So that's essentially the process of how to actually solve these. Now, let's look at a separate example using a different type of model. And maybe this model will make a little bit more sense to you. So let's say we have 1/4 plus 2/3. And for this model, I'm essentially going to use rectangles that I break up into pieces. So let's say we have a rectangle there and a rectangle here. And we're going to add these together. But this rectangle here, we want to model it using this fraction 1/4. So essentially, we have to cut it into 4 pieces. And what you'll see is you can essentially cut it in half and then cut each of those in half. And then drawing the lines down. So this is how our rectangle is split. It's split into 4 equal-sized pieces, or they're supposed to be equally sized. And then the numerator says how many of them we have. And so we just have 1 of those because the numerator was 1. And then over here we have this 2/3. We know that our rectangle is split into 3 equal pieces. So I'm going to draw 2 dots equally spaced and then drop the lines down. So these are supposed to be equally sized portions of this rectangle. And then again, the numerator just tells us how many of those pieces we have. So in this case, we have 2 of them. But this problem, like the last one, is that these pieces here and here, these aren't the same size. So what we have to do is find a common denominator. And like I say, you can always just multiply the 2 denominators together, and in this case, we'll get 12. And in some cases, there are easier or smaller denominators to use, but this is a method that always works. So if you forget the tricks, you can always fall back on this. So we know we're going to be changing this where the denominators are 12 in each of these fractions. So essentially, I have to divide up my rectangles into more pieces. Or for this model here, this 1/4, I would essentially have to break up each of these 4 blocks into 3 pieces. And over here, I'll have to break up each of these 3 blocks into 4 pieces. So let me do that really quickly. So what you can see is that I essentially decided to redraw these a little bit better and a little bit cleaner. And with this 1/4, notice that originally it was divided into these 4 equally spaced blocks, and we had 1 of them. But now it's been divided into 12 equally spaced blocks, and we have 3 of them. So essentially, we're going to be adding 3/12 here. But over here, we started with these essentially 3 equally spaced blocks, and we had 2 of them. But now everything's divided up into 12 equally spaced blocks, and it looks like we have 8 of them. So we're going to be adding 8/12 here. And since they're all the same size blocks, we can add them together. So our sum, when we add these together, would just be 11 divided by 12, since we have 11 of these blocks. And these blocks come from a rectangle that was divided into 12 equally spaced pieces. So this, again, gives you kind of a visual way to solve it. But as always, we want more of a mathematical way to do this. Because as you can imagine, if you create really big fractions, this visual model doesn't really help. It's just going to be too complicated to deal with that. So ultimately, you want to understand it from the visual model, but you want to be able to compute it using essentially an algorithm or a step-by-step process. So what I do is I look at this 1/4 once we find our common denominator, and then I ask, what do you multiply 4 by to get to 12? And since you have to multiply by 3, we have to do the same thing to the numerator. If you don't do the same thing to the numerator, then you're changing the number. Because notice, we're essentially just multiplying by 3 over 3. And 3 over 3 is just 1. And remember, you can multiply any number times 1, and it's still equal to whatever that number is. So all we're doing is just multiplying by 1 here. And with this 2/3, we're going to do the same thing. We ask, what do you multiply 3 by to get to 12? And we know you multiply by 4. So we'll have to do the same thing to the numerator. And this 1/4 would become 3 over 12. And this 2/3 would become 8 over 12. And again, once you find the common denominator and you've changed your numerators to the correct values, then you just add straight across the top. So you get 11, and our denominator always stays the same, because the denominator just tells us how many pieces, how many equally spaced pieces we cut our figure into. And I'm going to go through one more example, but without using a visual model. So let's say we have 4/7 plus 8 over 9. So we have some much bigger numbers here. And using some kind of model would probably be pretty difficult, because first we want to find a common denominator. So let me write that down. We want a common denominator. And you can always find that denominator by just multiplying your two denominators together. So we can do 7 times 9, which gives us 63. So our new denominator for each of these fractions will be 63. And then from here, we want to ask ourselves, what did we multiply 7 by to get to 63? And since we multiplied by 9, we're going to do the same thing to our numerator. And 4 times 9 is 36. And then what did we multiply 9 by to get to 63? And we multiplied by 7. So I'm going to multiply the top and the bottom by 7. And 8 times 7 is 56. And then once we've found our common denominator and changed our numerators, we're just going to add straight across with our numerators. And 30 plus 50 is 80, and 6 plus 6 is 12, so that would be 92. And our denominator is always going to stay the same, so that would be 63. So this right here will be the final answer when you add 4/7 plus 8 over 9.